and welcome to another tutorial video for CSCI 2824, Discrete Structures. In this video, we're going to focus on the biconditional proof, which is actually made up of two other proofs. Here's how a biconditional proof works. We have some propositional statement, P if and only if Q. We must prove if P then Q, and we must also prove if Q then P. Here's an example problem to go over this. Suppose we must prove n is even if and only if 3n plus 6 is even. The first thing we're going to want to do is prove that if n is even, 3n plus 6 is odd. For this, we're going to use a direct proof. As with all other direct proofs, we start by making an initial claim. Suppose n is even. By the definition of an even number, this means that n equals 2k for some k. This is because 2 times any number will always be even. Now, we can plug n back into the 3n plus 6 equation. So, 3n plus 6 equals 3 times 2k plus 6. And now, we're just going to do a little simplifying. So 3 times 2k plus 6 is actually equal to 6k plus 6. And 6k plus 6 can be written as 2 times 3k plus 3. Now, you might be noticing something, and that is that we have a 2 multiplied by some random expression, really. We note that because k is some integer, k plus 3 can be written as L. For some L. That means we have 2L, which is even. So, it's been proven that if n is even, 3n plus 6 is odd. However, because this is a biconditional proof, you'll remember that we still must prove this in the other direction, which means we must prove that if 3n plus 6 is even, n is even. This can actually seem like a little bit of a daunting task, which is why we're going to introduce another type of proof. This is the contrapositive proof. Suppose we have the statement, if P then Q. For the contrapositive proof, we switch this and then prove, if not Q, then not P. So instead of proving if 3n plus 6 is even, n is even, we'll prove if n is odd, which is the opposite of even, then 3n plus 6 is odd. Because this actually is about the same exact process as the previous portion of this proof, I've written out the proof for you here, so you can pause and look it over. Just note that for any odd number, n equals 2k plus 1, because any even number plus 1 will always be odd. After you've completed the proof both ways, then you're done. The biconditional has been proven. So, when you're doing a biconditional, remember that it must always be proven both ways. And remember that the contrapositive proof can be a very handy tool. Thanks so much for watching, and good luck.